First of all, thanks for being here in my YouTube channel. So friends, before watching this video, so do not forget to purchase my quantitative aptitude book on Amazon. In case if it is out of stock, you can directly purchase for the same price at our platform. The link is in the description. So friends, now let me move on to the 30-second data interpretation for the mains level exam. So here it's a caselet DA, right? So we have to read the passage. I think 3 DA, which we are from 30, 31, 32. Mostly we are solving a caselet DA. So they have given a passage here. So based upon the passage, so we have to read the complete passage, and either it's a table chart, you can frame a table chart, or write the values separately, and based upon the questions what they have given, we have to find out the answer, right? So interesting question. So I hope you have taken the test. So kindly, again I am saying, first write the same question, same numbers, everything is same what I am going to teach here. As a test I have given already 12 hours back. So first write the test, understand where you are struggling to solve a question, and then come and watch this video, so that you can able to learn that what are all the mistakes that you are doing while writing the test, or you don't know where the if you are struggling, right, on the concepts, basic concepts, so that you can learn all those things by watching the video. So now let me move on to this question. One day, ACH hospital, all the doctors were present. However, not all of them arrived on time, nor did all of them stay until the end of their duty shift. So while first point we can able to see the question was talking about some hospitals where all the doctors were present. So that means all the doctors were present. The total number of doctors was not given. So let's assume the total number of doctors as 100%. Usually we do this. We always assume as 100% as a base number. So similarly, we can assume 100% doctors were present. So now what they are saying is, however, not all of them arrived on time, nor did all of them stay until the end of their duty shift. So out of 100% of the doctors, every doctor was not arrived at the time. Some were late, or some were early, and some were on time, right? So now let's move on to the first point on that day. So some day, right? So let's take an operation day. Of all the doctors who arrived early for their shift, 20% left early, 40% stayed late, and the remaining left on time. So only 3 points they have given in the question. First point what they are saying is, of all the doctors who arrived early, and the second point, of all the doctors who arrived late. Third point, of all the doctors who arrived on time. So totally we have 3 points, right? So total number of doctors who arrived late, total number of doctors who arrived on time, and the total number of doctors who arrived early. So 3 data has been given, and out of 3 data, right, we don't know what is the total number of doctors here. So what we can do here is, just let me assume some value. We can assume that the total number of doctors who arrived early, right, let's take this as X, because we don't know how many total doctors are there in the hospital. So let's assume the total number of doctors who arrived early is X. Similarly, the total number of doctors who arrived on time is Y, and the total number of doctors who were late, which is Z. Let's assume. So if you add X plus Y plus Z, this will be the total number of doctors in the ACM hospital, right? Let's take this as a base value, X, Y and Z. Now, first point, of the doctors who arrived early. So we know that the total number of doctors who arrived early, we assumed it as X. So out of the doctors who arrived early, some of the doctors left early, right? And some of the doctors they left on time, and some of the doctors were left the hospital late, right? So either you can frame a table chart, this upon your wish, right? But I think we have only small data here, right? So only doctors who left early, right, early, on time, and then late. So I think I don't want to frame a table chart. In case if required, you can do that, right? So now what they are saying is, out of the total doctors who came early, right, so you can see 20% left early. We know that out of this X, we need to find what is 20%. So friends, just listen here. This is the important area to solve the question. Why? Because Always assuming a value is the most important part on the mains level competitive exam question. For example, if we have a ratio value 7 is to 10, example I am saying, you can assume this 7 is to 10 as 70, 100. Yes or no? Because when you cancel this, let's take this as A value and this as B value. So they have given A is to B as 7 is to 10. So what we do is we can assume this as 7x and 10x. Some people will do like that. And some people will take it as A as 70, B as 100. But some people will take it as A as 700, B as 1000. Whatever way you can take the number, because whatever the value that you are going to assume, the final answer what you are going to get will be same for all. But one thing here is, if you need to find what is 10% of the number, for example, for A, if you need to find what is 10% of the number, so people who assumed A as 700, finding 10% is easy. What is 10% of the number is 70. So total number of students who assumed the value of A as 70, finding 10% is easy, which is only 7. But people who take it as 7x and 10x, if you want to find what is 10% of the number or 20% of the number, so in this area, for example, if you take 7 and 10 as it is, A as 7, B as 10, at this point, if you need to find what is 10% of the number, which will be 0.7. I don't want to make a number complicated, right? Because if you go with a decimal values, there are more chances of making a mistake. If you are going to assume some value, based on the value, if you are going to find all the remaining one, make sure the assumed value, right, should be the final answer what we are going to calculate, that should not be on a decimal point value, or else we should not get in a fraction. So just listen here. If I fix here the early as x, we have to find what is 20%. Yes or no? Right? 20% of this number is definitely a fraction one. Because if you find what is 20% of x, you will be getting around 1 by 5. So I don't want answer to be in a fraction. So what I'm going to do is, I'm going to take the early as 5x. I'm going to assume the early as 5x. If I assume it as 5x, finding 20% of the number is easy. Why? Because what is 10% of the number? So 10% of the number will be 5. 20% of the number will be 1. So we can say that the people who arrived early, right? So total number of doctors who arrived early, out of this doctor, total number of doctors who gone early, which will be x. So friends, understood or not how I found this? So this is the most important part of the question. If you can able to understand this, solving the complete question is easy. So once you can, it's upon your wish. You can assume it as x and you can solve the question. You are going to get the same answer. But the problem is, if you are weak in mathematics or if you are struggling to solve some of the max numbers, then always don't go with the decimal point values. If you go with some decimal point values, then finding an answer will be difficult. So I don't want to get any decimal point numbers. So what I am doing here is, instead of assuming it as x, I am taking it as 5x. If I take it as 5x, finding the 20% of the number is easy. So 20% is 1 by 5. So I can cancel 5 and 5 here. So we can say that out of 5x, the doctors who left early will be only x. In case, instead of 5x, if we are assuming it as only x, then finding 20% will be 20 by 100, which will be 1 by 5. So 1 by 5x. So 1 by 5x will be the total number of doctors who left early. Whether x is easy or 1 by 5x is easy. So I would always prefer going with a normal integer number. Because if the numbers are in a fraction, if the numbers are in a decimal point, definitely I will make a mistake. So that's the reason assuming a value is the most important part in most of the difficult level data interpretation. Because some questions we can able to see while I am solving, I will assume it as 100%. On some question I will take that as 200%. Why? Because if I keep 100%, I am getting an answer in some decimal point value, 33.33, etc. But on the same number, if I have take it as 200%, I won't get any decimal point percentage number. So that comes only in practice. If you didn't learn that, kindly learn by watching this video how to assume a value. So now it is easy, right? So the total number of doctors who left early will be 20%. So now next point is 40% stayed late. So out of this 5x doctors, right, how much of doctors stayed late is 40%. So 40% of 5x. So just see, out of this 5x, what is 40%? So 40 by 100, so we can cancel 0, 0. So 2 times 5 times, cancel 5 and 5, resultant will be 2x. So 2x will be the total number of doctors who left late, right? Yes. Who total number of doctors who stayed late. Out of this, doctors who arrived early, and the doctors, 2x of doctors who stayed late. Right? So the remaining will be on time, right? That's what they have mentioned it. And the remaining left on time. That means 2x, x will be 3x. Out of total 5x, 3x doctors were late and early. So the remaining x will be the total number of doctors who will be on time. So friends, understood or not how I calculated this? So this 3 value, once you understood how I found this 3 value, then solving the complete question is easy. Right? So first try to understand the question properly, what are all the values they have given here, and try to figure out all these values. So first we have assumed it, and this 5x is what? Out of total doctors, the doctors who arrived early. And what is this 3 value? Out of the total doctors who arrived early, some doctors left early, some doctors left late, and some doctors left on time. So these 3 data's percentage they have given in the first point. 20% of the doctors who left early from the doctors who arrived early. So why I assumed it as 5x? Just now I have told you, if I assume it as 5x, I will not get any value in a decimal or in the fraction. So I have assumed it as 5x. So x will be the total number of doctors who arrived early. And what they have next point, 40% of the doctors were late. So out of 5x, I have calculated what is 40%, which will be 2x. So 2x will be the total number of doctors who left late. So the remaining will be on time. So late and early total will be 3x, and the total number of doctors who arrived early is 5x. Out of 5x, when you eliminate 3x, remaining will be 2x. That 2x will be the total number of doctors who were on time. So friends, understood or not how I found it? So similarly, based upon the remaining point, we have to find the remaining value, right? So this let's take this as early, and this will be on time, and this will be late. And similarly, the second late value has been given. So now let's calculate the on time value. Where is the on time given? Is on time value. Okay, so on time value they have given as a last point. So now let's solve the on time value. So the third point I am reading, not the second point. So third point here is, of the doctors who arrived on time, we have assumed it as y. Based upon the percentage value, we can assume it as a different value. So 37.5% left early. So when just see here, out of the doctors who arrived on time were 37.5% of the doctors who left early. If you find 37% of y, you will not get an answer in terms of an integer, because you have to know what is 37.5%. 37.5%, if you convert into a fraction value, which will be 3 by 8. So 3 by 8 is the fraction value of 37.5. So 3 by 8 of y, again you will get the 3 by 8 of y. I don't want the answer to be in the terms of fraction. So friends, just now I have told you. So what value you can assume here, so that the complete value should not be in terms of a fraction. If I assume y as 8y, then I can cancel y and y here. My final answer will be in the term of integer. So friends, understood or not what I did is, right? So instead of y, if I assume it as 8y, finding 37.5% is easy for me. So what I am going to do here is, the total number of doctors who arrived on time, let's take this as 8y. So now what the question says, 37.5% left early. 37.5%, which is 3y. So 3y is the total number of people who left, total number of doctors who arrived on time were left early is 3y. So this is the way you have to assume the value. What is the next point? The same percentage stayed late and the rest on time. The same percentage, that means the same percentage were stayed late. Same percentage we found 3y. So 3y people were stayed late. So this is also 3y because both are same. At last what they are saying is and the rest, the remaining left on time. So 3 plus 3 is 6. So total is 8y. So 8y, 6y will be 2y. So 2y will be the total number of people arrived on time. So friends, left on time. So friends, understood or not? So this is the easy technique where you can solve the question easily. If you are going with the fraction value, then yes, you can. Many students usually ask me, why can I take it as a fraction value directly? Yes, you can. But calculation part will be little bit difficult. Why? Because you have to take LCM, you have to frame an equation. So those part will be difficult, but other than that, everything will be easy. So now the third late, right? The second point. Just a moment. Yes, second point. So of the doctors who arrived late, 50% stayed late. So now we have assumed this as 5x and 8y, and at last the total number of doctors who arrived late. So based upon the first value, right? First value what they have given us of the doctors who arrived late, okay? 50% stayed late. So similarly of the doctors, some doctors will be early and some doctors leaving on time and some doctors were late. So now according to the question what they are saying is 50% of the doctors were stayed late. So 50% of the number, 50% of the number is what? Half of the number. If you assume this as z, only z, 50% will be 1 by 2 of z. Again I am getting in a fraction value. I don't want to get in a fraction. So let's assume this as 4z. If you assume this value as 4z, what is 50% of the number? 50% will be 2z. So 2z will be the total number of doctors who left late from the doctors who arrived late. Right? So similarly, the next point is 25% on time. 25% is what? 1 by 4. So 1 by 4 of the doctors were on time. So 1 by 4 is into 4z will be only z. So z will be doctors who arrived on time. Late will be 2z. So 2z, z, 3z. So remaining will be only 1 z. So early will be z. That's the point. And the rest will be left early. So and the rest will be left early. So z, z and 2z. So friends, understood or not, right? If you wish, you can frame a table chart that is completely upon your wish. But if you solve more number of question, case-led question, you can have a proper format, right? Like this. Some questions I have solved it on a table chart. Why? Because if it is a lengthy process, for example, 4 colleges has been given, 5 different subject has been given. So on those cases, I would always recommend you to go with a table chart. But if the values are smaller, just only 3 points they have given. So what I am doing here is I am just taking a note of each and everything in a proper way, so that we won't make any mistakes, right? So friends, understood? I think the remaining part other than this solving will be easy. Okay, anyway, I can solve and show you how to find out the answer. So now what is the other data they have given here is the last point what they have given is, just a moment. Yes. So the last passage, friends, last passage what they have given below the 3 point is the number of doctors who arrived early was equal to the number of doctors who left on time, and the number of doctors who left early was 39 more than the number of doctors who arrived late. The number of doctors who did not leave on time was 144. So totally they have given 3 points, right? What are all the points they have given here is, first point, the number of doctors who arrived early was equal to the number of doctors who left on time. This is the first point they have given, which is equal. So equal means you have to equate the two equations. So first equation what they are saying is the number of doctors who arrived early. So number of doctors who arrived early is what? 5x. So 5x is the number of doctors who arrived early, which is equal to, so this value is equal to the number of doctors who left on time. So the number of doctors who left on time, this is the number of doctors who arrived on time. The number of doctors who left on time is, this will be the number of doctors who left on time. This will be the number of doctors who left on time. And this will be the value, the total number of doctors who left on time. So you have to add these three values. So 2x plus 2y plus z. So friends, understood or not how I wrote this equation? So the total number of doctors who arrived early, which we have assumed it as 5x, which is equals to the total number of doctors who left on time. So this value is left on time, first value. This value will be the total number of doctors who left on time, and this will be the total number of doctors who left on time. So now what we can do here is, so 3x is equals to 2y plus z. So let's assume this as equation 1. So equation number 2. So based upon the point, we have to frame the equation, right? So second equation is, and the number of doctors who left early was 39, the number of doctors who left early, right? The total number of doctors who left early. See, early will be x, early will be 3y, early will be z. So 3 equations. So x, 3y, z. X plus 3y plus z. So what they are saying is, this doctors left was 39 more than the number of doctors who arrived late. See, which is equals to 39 more than the doctors who arrived late. So who arrived late is how much? 4z. So 39 plus 4z. So you have to simplify this equation now. So x plus 3y, so minus of 3z is equals to 39. So let's take this as equation number 2. And what about the equation number 3? Third point. So third point, what they have mentioned is, they have given the total. So total number of doctors who did not arrive on time. If the doctors who did not arrive on time, that means the total doctor early and late. So early is how much? X. Late is how much? 2x. So 2x plus x will be 3x, because the total number of doctors who were not arrived on time. So that will be the total number of doctors who arrived late, as well as the total number of doctors who left early. That will be the total number of doctors who does not arrive on time, right? So let's take x and 2x will be 3x, 3y will be 6y, and 2z, z will be 3z, which is equals to 144. So this will be the third point they have mentioned here. So now what is the target? Our target is to find, so we have to solve the 3 equation in order to get x, y and z. So I think the only easy way is, if I find one value, finding the remaining is easy, right? Because the complete value itself, we have assumed x, y, z here and there. So if I need to find one value from this equation, it is easy. So when just see here, 3x, here also I have 3x, 6y, 3z. So if I multiply this equation 1 by 3, so this becomes 9x, this becomes 6y, and this becomes 3z. So friends, understood or not what I did here? Right? So first I have just multiplied the first equation by 3, so that this becomes 9x, 6y and 3z. So we already have in the third equation 6y and 3z. So 6y and 3z, which is equals to 9x. So instead of 6y and 3z, we can substitute here as 9x, which is equals to 144. So 12x is equals to 144. So x is equals to 12. So finally we got the value of x, which is equals to 12. So once you got the value of x is equals to 12, so the total number of doctors who arrived early will be 60. And if you know the value of x is equals to 12, finding these 3 values will be easy. Similarly, finding y and finding z based upon this equation is easy, because once you find one value, substituting in, if you substitute x here and substitute x here, you will get y and z. So y and z, if you simplify the equation, you will get what is the value of y and what is the value of z. Right? So very simple and easy. Not the complete question, very simple and easy. This part alone I am saying, but the question complete part is not that much easy, but assuming the value is the important part here in the question. You have to assume the proper data, right? Only if you take a proper value from the given data of the question, you can able to find out the answer clearly. If you are okay with the fraction, you can assume x, y, z. If you feel that fraction value you will make any mistake, assuming the value is important. Starting of this video I have told you how to assume a value, right? So if it is 37.5, we know 37.5 is 3 by 8. So instead of assuming it as y, if I take it as 8y, we can cancel an 8 and 8, so that the value will not be in a fraction value, we will get directly as 3y. So instead of that, instead of assuming it as y, I have assumed it as 8y. So similarly, instead of assuming it as only x, I have assumed it as 5x, because finding 20% is easy. So when you practice more number of questions, automatically you will get how to assume a value. So this kind of part will able to see on the tough level competitive exams, not on the prelims or not on SSC, railway. So those competitive exams you won't see this kind of question, but only if you are preparing for a bank mains or CAT exam mains, you can able to see these kind of question. So friends, I think solving all the question, if you find XYZ, I hope you can able to find all the remaining 5 question on the test. So that will be easy. So you don't want to worry about it. Only thing is framing a table chart alone feels difficult. So friends, thank you so much for watching this video, and if you really like it, share this video to your friends, those who are preparing for the competitive exams. So thank you so much.